Hi class, so today we're so close. We have 2 days left. So today we're gonna start some different review. We're gonna do review of factoring. Okay, we're gonna split factoring up between today and tomorrow. And class, I know we're at the end. I know we wanna be done. I know we're tempted to just sort of throw things down and check things off the list. But if there's anything, right, I told you this at the start of the trimester, this is one of the most important topics we do all year. It's something that's going to continue to come up in future math classes. So we made the decision to sort of cut some different standards and not do anything new for these days because factoring is just that important and we need to make sure you know how to do it. So since we're not reviewing for final exams and you don't have finals, we're going to do this sort of in replace as a review. So we're going to start factoring review by looking at two different types of factoring. We're going to look at today factoring by factoring out of GCF. And the other type of factoring we are going to look at is factoring by grouping. Okay, all of these are based on the idea that we can factor out of GCF, and all of these are things we've already done and tested. You did them with me in the classroom before all of this stuff started. Okay, so remember, a GCF is the greatest common factor. And it is always what we want to consider first. So it's always sort of our first point of, does a problem have a GCF? So if I'm given something like 16x to the third, excuse me, plus 24x squared. Okay, when we look at this, we're going to ask ourselves, okay, what number goes into 16 that will also go into 24? Now, the hope is that we can get the largest number to start with, but as a reminder, that doesn't always happen. So I'm just going to show you an example of what if that happens? What if you don't get the largest number? So remember, we would say, okay, well, I know 2 can go into 16 and into 24. And then we would check and see if they both have the letter, they both have the variable, which they do, and if they both have it, then we will choose the smaller exponent. Okay, so the smaller exponent is 2. So I'm going to factor out or divide out a 2x squared. So 16 divided by 2 is 8. And remember, when we divide with exponents, we subtract them. So 3 minus 2 gives us 1. 24 divided by 2 is 12. And 2 minus 2 gives us 0. So there's no more x to write down. Now, before we say we're done, we're then going to ask ourselves, is there anything we can think of that goes into 8 that would also go into 12, right? And if we don't get that GCF to start with, we can then catch it here, right? And we can divide again. So 8 divided by 4 is 2. 12 divided by 4 is 3. Now, if you have to divide more than once, remember you need to take both of these and you need to multiply them. So 2 times 4 is 8, so we get a GCF of 8x squared. And when we're factoring, right, that GCF goes out here in the front in parentheses with the idea, right, that just like what we reviewed yesterday, I could multiply this back out and get back to where I started, right? So this would be my answer here. Now, if you get that GCF to start with, that's awesome. You can always just pull that GCF out straight from the very beginning and then not have to worry about multiplying the two things that you divide and just divide one time. Okay, the other piece is that we then used that factoring out a GCF and we applied it to factoring by grouping. So let's say we have something like 6x to the third plus 9x squared plus 2x plus 3. So this is factoring by grouping. Okay, and we said we did factoring by grouping when we have 4 terms. So we have 1, 2, 3, 4 terms. So if we had 4 terms and we were going to factor by grouping, we would chop this in half and we would think about it as 2 separate problems. Okay, where each side I'm going to factor just like I did up here on the top. So I'm going to look at 6x to the third and 9x squared and say, okay, can I think of a number that will go into both of them? Okay, well, they're both divisible by 3. They both have the variable and the smaller exponent is 2. So I can then factor out a 3x squared. When I divide that out, 6 divided by 3 is 2. I subtract, 3 minus 2 is 1. 9 divided by 3 is 3, and then 2 minus 2 just cancels out and goes away. Okay, so I ignore that half. Now I'm done with it. So now I'm going to look at the other side, and I'm going to do the same thing. So what goes into 2, that will also go into 3. And remember, there is always technically an answer, right? We can pick a 1. They don't both have the variable, so I can't pull out an x at all. Okay, so this just leaves me with a 1 times a 2x plus 3. And our whole goal when we're factoring by grouping is that we want those two binomials to match. So if you don't get those to match, you did something wrong. Or I made a typo, send me a message, I messed something up in Canvas. I think I double checked. But, okay, so then we're gonna take these two numbers and put them together. And we write them side by side in one binomial. So I'm gonna write my 3x squared. And this is a positive 1. And then my other binomial is the 2x plus 3. And so that would be my final answer. Okay, then we are going to look at one more. And again, if you need more problems to review, you can always go back to previous in the trimester, just on the home page, click previous ones, and you can just find where we did factoring by grouping in Canvas. And there'll be all the extra class videos and class notes and all that stuff. Okay, so let's say we want to factor 4f, I lost my place, 4f to the third plus 10f squared minus 8f minus 20. Now remember, our real goal when we're factoring is always to factor completely. So while I showed you, right, this is how we factor by grouping and this is how we factor a GCF, our long-term goal is always, how do we put those all together and factor completely? So the first thing we're gonna do is ask ourselves, does this have a GCF? And the answer to that question is yes, we can pull out a 2. Now remember, we have talked about in class that if you miss that GCF to start with, you can pull it out at the end, but getting those numbers as small as possible to start with is always helpful. These do not all have the f, so I can't pull out an f. So I'll get 2f to the third plus 5f squared minus 4f minus 10. Now I can't think of anything that will go into all 4 of those terms, so I know I got the GCF out, and so I can put this 2 out in front. Now, once we've done that, we've done some factoring, but we haven't factored it completely. So the next thing we want to do is factor on this piece, or focus on that inside piece next. And we'll say, okay, so I have those 4 terms. Now let's factor those 4 terms by grouping. So I'm just going to kind of ignore that this is sitting out here. And I'm just going to start factoring this by grouping. Okay, so what goes into 2, that also goes into 5, that's a 1. They do both have the variable, so the smaller exponent. So that will give me a 2f plus 5. You can write that 1 in front of the f squared, but you don't need it. Okay, then we're going to do the right-hand side. What goes into 4, that also goes into 10, that's a 2. Now, here's a piece we might need to be reminded of. Remember, when this leading number is negative, so just here in front, doesn't matter over here, when the leading number is negative, we want to make our GCF negative. And the reason why we do that is because it's so important that it matches this binomial, and this one's positive, so we need to pull that negative out. So a negative 4 divided by a negative 2 is a positive 2, and a negative 10 divided by a negative 2 is a positive 5. Okay. So now we'll have an f squared minus 2, putting my 2 GCFs together. These match up nicely, so that's my other one, a 2f plus 5. And then my GCF of 2 in front. Feel free to, if you need more examples, to reach out to me. Or again, like I said, go back to previous days in the trimester. Everything is still listed on the calendar. You can find when we were doing factoring by grouping and see some more examples there as well.